Alrighty. Hey guys, welcome to class. My name's Professor File Sticker. You guys can call me Professor John or JP or whatever makes you all comfortable. This, of course, is Calc 2, MAC2312, and I'm excited to meet you guys and get started here today. We're going to do a handful of things. First, I kind of want to introduce you to the environment I'll be using. I'm going to turn on a screen share here, and then we can get rocking and rolling. Please do allow the screen share, and I'll ask that you leave it up maximized because I'll be writing some things, and that way you'll be able to actually see them. So here's what class is going to look like most of the time. This is a document camera. I found that it works better in the online setting than like trying to videotape myself in front of the board you see behind me because markers die and all sorts of crummy things happen. I'll start class each day. Well, it might seem a little bit redundant, but reminding you where we are. So this is MAC2312, focus, section 004. Today is a lecture, and the date is the 5th of January, 2021. Sometimes this thing takes a second to figure out its settings. There we go. Come on, focus. All right. So today we're going to do a few things. We're going to go over the syllabus. I know that sort of first day stuff is usually a little bit boring, but then we are going to get into some mathematics. We're going to review a section of the textbook that is supposed to be covered well in Calc 1, but often isn't. Most people just call this technique U-sub or integration by substitution. And we're going to talk a little bit about areas, specifically areas between curves, which is section 6.1. And we might talk a little bit about average value, which is section 6.5. But before we get to any of the actual mathematics, I want to run through the syllabus, make sure everybody has a clear idea of what's expected from you in the class, where your grades are going to come from, all that good stuff. So zeroth things zeroth. If you haven't done this yet, of course, you're all here, so you found this announcement. But go to the home page in Canvas, and please download the course syllabus. Save it somewhere safe on your laptop. You can view it on your phone if you want to, but I found that these things often don't render as well on mobile devices as they do on a PC or whatever, you know. So click here, save the file that pops up, and it will look like this. I'm going to run through the fine points of the syllabus, but we're not going to do everything in super duper detail because, you know, time is valuable. So this is my name, last name pronounced File Sticker. Don't stress if you mispronounce it. My office is A031D on the main campus, but you won't find me there if you go looking for me there because we're doing everything remotely still. Email is by far the best way to get a hold of me. This is a mail to link, so you can just click on that. It will open up whatever you use for email and address the email to me. In your emails, if you could please put MAC2312 in the subject before whatever else you want to say. That way I can set up a filter and everything will be easy to organize. This phone number does work. It's my office phone number, but it's forwarded to my cell. I'll ask that you don't call this unless it's like an emergency because caller ID doesn't work. I just see that I'm getting a call forwarded from my office, so I can't tell who it's from. I would much prefer email or Canvas messages for communication. Class meetings, obviously Tuesdays, 12:30 to 1:45, and then Thursdays, I've got it marked here as 12:30 to 3:15. Really what that is on Thursday we'll have a 12:30 to 1:45 lecture and then a 2 to 3:15 lab. But because there's a 15-minute break in between there, it's really not a substantial enough amount of time that I'll just do one Zoom meeting for Tuesdays and one Zoom meeting for Thursdays. And on the Thursdays, it will be this long time. I'll give us a little break. You know, we can stretch our legs and do whatever. We'll take a few minutes between the 1:45 stop point and the 2 o'clock start point for the lab. Office hours, these are not set in stone, and if these do not work for you, I'll ask that you send me an email or Canvas message so I can add some which do work. But right now I've got them set as Monday, Wednesday, Friday from 1 to 2, and Tuesday, Thursday from 11 to 12. And I'll show you how to join the office hours. They are Zoom meetings. If you look here in Canvas in the main home/syllabus page for our Canvas class, if you click on this link, that will join the meeting for the Monday, Wednesday, Friday office hour. Obviously, it only works between 1 and 2 p.m. And if you click this link on these days and times, that will join you to the Tuesday, Thursday office hour. I do have a waiting room set up there because sometimes people like to discuss things in private during an office hour. And I don't want someone just popping in while we're talking about grades or something like that. That needs to be confidential. So if you join, you may have to wait for a minute in that waiting room. If I see somebody languishing in the waiting room for more than a minute or two, I'll try to send you a message letting you know that I'm here and that I'll bring you in a minute. But yeah, when you come to the office hours, you'll be put in a waiting room. And then if you feel like it's been a while and you haven't heard from me, feel free to send me a message through Zoom if you've been sitting in that waiting room for a while. Another thing I would like you guys to do right now, go ahead and grab out your phones or whatever you use to keep track of dates and times and throw this in there. This is the final exam. It's going to be April 27th from 1 to 3 p.m. And I would recommend putting that in there with like a 2-day notice and a 2-hour notice, you know, at least 1 or 2 little notifications to say, hey, the final's coming up. Because it would be tragic if you missed that. As far away as it is, we want to be proactive there. Of course, the second link down here is the syllabus. I mentioned that a minute ago. This first link takes you to WebAssign. I'll pop that open in a new tab. I think I'm not logged in. Okay. So if you haven't registered for WebAssign yet, you would click this gray button and enter the course ID from the syllabus. That's this thing. You can copy paste it out of the syllabus. And at some point in that registration process, they're going to ask you for an access code, which is like the proof of purchase, right? It's how you show that you paid for WebAssign. If you already have your access code, go ahead and put it in at that moment. If you do not have your access code, scroll down on that page just a little bit and you will see I think it's like a white or gray link that says click here to start temporary access or to start trial access. That will get you into the class so you can start on the homework right away, even if you haven't bought your access code yet or if you're waiting for it in the mail or whatever. So there's no reason why everybody shouldn't be in WebAssign at some point today looking at our class. If you don't have your access code, just look around on the page where it asks for the access code. There will be a link somewhere that says start temporary or trial access. That'll last for 2 weeks. And after 2 weeks, if you haven't purchased and input an access code, it will boot you out. So it's very important that within the next 2 weeks, you do go ahead and buy an access code and input it. Again, if you already have yours, that's not a problem. But if you don't have your access code yet, please still register, get into the class in WebAssign, start on this homework today if at all possible, and then make sure you pay for and input your access code within the next couple weeks. I'll talk more about that homework assignment in just a minute. Other important stuff for this class, right? Class meetings, office hours, final we talked about. Everybody probably knows the prereqs because you've already done them, otherwise you wouldn't be here. The textbook is Stewart, which is a classic ancient textbook. It's been around for like 40, 50 years at this point. We're on the 8th edition. You don't need to buy a hard copy of the textbook, and you'll have access to an electronic copy of the textbook through WebAssign automatically when you get into WebAssign. If you do want a hard copy of the textbook, or if you want a soft copy that is a little easier to navigate, you can reach out to me and I can help you find one of those. WebAssign access code, I explained this already. This is what you need to tell WebAssign, yeah, I want to go into this guy's class, right? This particular version of Calc 2 that's being run by Professor Filesticker at Santa Fe College. This is the code you give them there. I forget what they call it. What was it? Class, it's not, I think class key, yeah, not course ID. Calculators, this is important. So on the exams, you're not allowed to use a graphing calculator of any sort. That means no TI-83, TI-84, 89, Inspire, none of that. No Desmos, no nada. If you want to have a calculator on the exams, this is the only one that's allowed. The TI-32XS. You won't need a calculator. All right, I want to say that right out of the gate. None of the problems that I give you are problems that will be heavy in arithmetic or that sort of computation where we need to lean on a calculator. And the department chose this one specifically because it doesn't give you exact values for trig functions. So you need to know your unit circle. If we've been leaning on calculators for unit circle type calculations, that is ending in this class. So you got to know that unit circle. If you want a calculator, this is the one you can use. But you do not need a calculator at any point in this class. In the homework, I do recommend that you use Desmos, Wolfram, whatever you like to check your work, to look at more examples, to see if you change the 2 to a 7, what happens to the answer. All that sort of stuff is really good. And I'll use Desmos a bunch in class, so you'll be able to get a feel for kind of how Desmos works and how it can be useful from the lectures. Another thing you will need is a computer with the web browser kept up to date. So if you have automatic updates turned off for Chrome, I recommend turning those back on because we will be using HonorLock to proctor exams. HonorLock requires that the Chrome browser be kept up to date in order to function correctly. Another thing you'll need, of course, is consistent web access. The lectures are through Zoom, but the proctoring is also done over the internet. I'll talk a little bit more about test proctoring when we get to that part of the syllabus. But you need to make sure, especially on exam days, that you're somewhere you have good, reliable internet access. I know sometimes some apartment complexes in town, internet can be a little bit spotty. So if you know that to be the case where you live, that like from time to time the internet goes down for an hour or two, really recommend setting up a plan B. Having an alternate place where you can scurry to and take your test if you need to is a really good thing to have. So if you know your internet access to be a little bit spotty, just establish a plan B, something that you can run to if you need to. Webcam, of course, also required, not just for the Zoom meetings, as lovely as it is to see all of y'all's face. Again, for proctoring, it's necessary. Course description, we're going to pick up where you left off in Calc 1. So Calc 1 finishes with a somewhat robust discussion of the definite integral, indefinite integrals, U substitution, maybe even a little discussion of areas between curves. I'm going to pick up right about where those leave off with U substitution. We're going to move very fast through U sub because that's supposed to be covered thoroughly in Calc 1. We're going to move very fast through areas between curves because, again, it's supposed to be covered in Calc 1. And we're going to pick up from there, looking at other things you can do with integrals, like calculating this important thing from statistics called average or mean value of a function. We're going to look at a lot of different tricks for integrating functions. All of Chapter 7 in Stewart is like different methods for solving integrals. Then we're going to jump to talking about sequences and series, which are these totally different objects, but they're very foundational in mathematics. That middle part of the course where we talk about sequences and series tends to be the hard part, the part that people are afraid of, specifically power series. We'll get there when we get there. After we get through power series, we're going to talk about parametric and polar coordinates. We'll look at some other applications of the definite integral. And if you want to see a full list of the topics for the class, you can click that link in the syllabus. It'll take you to Santa Fe's kind of overview page for Calc 2. Good to take a little look at that. Maybe in your own time because it doesn't want to load. Cell phone policy, this is less important now than it is in an in-person class, but just don't use tech in any way that distracts other people. It's really important that we create a nice inclusive environment. If you are here, you belong here, period. There is nobody here who does not belong here, and it's really important that we don't distract other people or mislead other people or do anything that in any way disrupts the learning experience for your classmates. And that includes, keeping a really healthy and pleasant form of discourse in the class where we're respectful and kind to each other. But it also means, not sharing memes in chat, that sort of thing. So let's keep it polite, professional, respectful, so everybody gets what they should out of the class. And the second part is especially important. The way I'm going to be proctoring this semester is a little bit different. If you've taken online or sync classes with me in the past, I used to just use HonorLock, but that shit don't work. So this semester, we're going to be using Zoom on your phones in addition to HonorLock. So the way it'll work for tests is you guys are going to sign into HonorLock like you normally would, but you're also going to set up your cell phone on the side of your workstation and sign into Zoom. So that will give me a view of your desk, your hands, your paper, through Zoom, while HonorLock records your face, computer, and web traffic. This is really the only way I've found that's able to combat the levels of cheating that we've seen in the last few months. I'll talk more about that later. Attendance, there is no attendance component to the grade, although I will be taking roll. You don't have to worry about like signing in or saying I'm here. The Zoom logs will take care of all of that for me. Just please use your real name in the Zoom logs. Whatever name is on your Santa Fe ID, that's the name I would like you guys to sign into the Zoom meetings with. That way I can compare that to the class roster and easily take roll. Very important for financial aid that I get the attendance reported quickly so your financial aid is released. And so I'll ask, please just use your real name in the when you sign into Zoom. Makeup policy. So I'm very loose about homework. You can do the homework pretty much whenever you want. There are due dates, and the way I structure the homework, I'll talk about in a little bit, but basically if you miss a homework assignment, if it drifts by, it's not done, whatever, WebAssign has a mechanism for you to request extensions. Let's see, I don't know if it'll show me the student view here. No, but you guys have an option to request extensions once you're into a homework assignment. If you need more time on a homework, just request an extension. I'll go through a few times a day and clear those out. There's no point penalty, no nothing. But try to keep up with the homework. In the little welcome announcement I posted in Canvas, I mentioned how important it is that you stay on top of the workload. I cannot emphasize that enough. After class every day, you should solve at least 2 or 3 problems like immediately to help sink in the stuff that we talked about. If you don't do it on your own and you don't do it right away, you'll be amazed how much you can forget just on the drive home or just, you know, going and taking another class for a few minutes or whatever. Stay on top of the work. Solve some problems immediately right after class, and then make sure you're doing the homework to completion every week. If you miss something, happy to help you make it up. Don't worry about it, but try to stay on top of it. That's the #1 predictor of success in this course, is just doing the homework on time. Exams are a little bit different. If you miss a test, really a test should never be missed without prior communication. If you know you're going to be out of town or something is going on that you cannot be present on the day of a test, let me know as soon as you can. I'll schedule a makeup. It just has to be, the makeup has to be done within a week, right? So we need to talk about it and get the makeup sorted out within 1 week of the missed test. If you miss a test due to, you know, acts of God or some unfortunate crazy circumstance, I'll be understanding there. Try to get me some sort of documentation, but the same rule applies. Just as long as we knock it out within a week, I don't really care, as long as you're getting it done. So here's the section on the homework. Every week I'm going to release a homework set on WebAssign. Your first homework set is already up. It should be visible to you at the end of class. It might even be visible already. And then they will be due at the start of class the following week. So your homework 1 is up right here. It's already here. And this is going to be due at the start of class, so 12:30 next Tuesday. And that's the way it will always work. I'll pop open the homework when class ends on a given Tuesday. It'll stay open that whole week until class starts on the following Tuesday, and that's when it will be due. Again, if you are late on something or you haven't finished it, just request an extension. I'll leave it open a little bit longer for you to go in and finish things up. Study guides are different. Before each exam, I'm going to publish a special homework set in WebAssign. The study guides, you need to answer the questions in WebAssign, but that's not where the study guide score comes from. Study guide score comes from you writing out nice, neat, careful solutions to those study guide problems, scanning them. I recommend the app Cam Scanner for Android. I like it a lot. I've been told that the iPhone users can use the Notes app to do this. And then uploading those solutions to Canvas. So in order to get credit for the study guides, you'll come into Canvas under Assignments, go to the study guide here, and you'll upload your scans of the solutions to the problems from the associated set in WebAssign. So like a week before exam 1, you'll see a homework set in here titled, study guide for exam 1. You'll go in and solve those problems, and then just save the paper, right? The paper that you use to write out and solve those problems, save that, scan it, submit it here. You want to do that as soon as you can. That way I can get you some feedback on your written work before the test. And the intent is for you to bring those study guide problems to office hours, bring them to class, share them with other people, talk about the solutions, preferably with myself, before the test. That way I can say, oh, well, here, you wrote this, and over there you need to write that, or make sure you don't skip this step. All the little things that I would take off points for on a test, I want to tell you about those on your study guide. That way you can fix them and not lose those points on the test. That is that. Lab meetings, lab is a little bit weird right now. Normally, the way I run labs, you guys would come up to the boards and solve homework problems for extra credit on the upcoming midterm, whatever that next midterm is. I haven't found a good way to do that online yet. So right now, labs are mostly just extra lecture. But I'll try to make our lab meetings focused on problem solving. So Tuesdays and Thursdays, the 12:30 to 1:45 portion of class will be regular lecture. And then on Thursdays from 2 to 3:15, we'll just be solving problems. And I'll try to find some way to integrate this bonus point thing in here, maybe through polls or something like that. The exams themselves, there's going to be 3 midterms and 1 final. The midterms are in Canvas, proctored with HonorLock, and we'll be doing that secondary proctoring through Zoom with the cell phone. If you don't have a working webcam or you need a laptop that's more functional than what you have access to, let me know. Santa Fe has loaner laptops. I can help you get a webcam, but it's very important that you have the hardware necessary to run HonorLock, and then separately from that, you need to be able to run Zoom on your phone. So the proctoring is going to be twofold. Right, we'll do the HonorLock standard thing, and then you also need to have Zoom installed on your phone, and you'll set that up on the side of your desk, showing your hands, your workspace, your paper, so I can actually watch what you're writing. I will be on those Zoom calls popping in from time to time. You know, hey, what problem are you working on? How's it going? Can I give you any tips? The sort of stuff that you would normally do during a regular in-person class. I'll like, instead of walking around and asking you how's it going, are things okay, I'll be doing that through Zoom. So very, very important, we have the hardware necessary. If you don't have a phone that can run Zoom, or you don't have a computer that can run HonorLock, let me know, and I will find a way to get you that hardware. A little notice about recording. All of our lectures, including this one going on right now, are recorded. I record them locally on the computer here, and then I upload them to YouTube after the class is over. This is so you guys can review the lectures, review the examples, and God forbid you miss a lecture, you can go back and rewatch it. Be mindful that if you have your video feed on, then you will be captured in the recording and it will be up there. So if you're extra shy, you may want to turn off your video feed during lectures. And the same sort of thing goes for the exams. During the exams, HonorLock will be recording your webcam, Zoom will be recording from the phone, and I'll be reviewing those things. So you want to be a little bit mindful of where you are and what you're wearing. The following dates I really recommend putting in your phones. So classes begin, of course, you know that, but the 7th, Thursday, is the last day to add a class. So if you decided you wanted to drop this class and add another one in its place, even though you can drop all the way up to the 11th, you can't add past the 7th. So drop and add have separate dates. The last day to add a class to your schedule is the 7th. The last day to drop a class and get your money back, no mark on your transcript, is the 11th. So those are especially important. Look over your schedule, think about your time commitments, and make sure that you're in a situation that is manageable according to those dates. The 18th of this month is Dr. King's birthday, so there will be no class. The college is closed then. Spring break is March 3rd through March 13th, so of course there will be no class then. The 24th of March is the last day you can bail on this class without an A through F letter grade being assigned. So the last day to get a W, a withdrawal, rather than an A through F letter grade is March 24th. And as that date gets closer, I'll remind you, and I'll share with you a little bit my kind of standard advice for, you know, should I stay in the class or should I not? But just be aware, that's the last day to withdrawal. And then a month after that, on April 24th, is our last day of class, and the final exam, like we mentioned earlier, is the 27th. Yeah. Grades will be posted by May 4th. The grade in the class comes from a combination of homework, exams, study guides, but most of it comes from the exams. So you can see it's broken down in terms of points and percentages here, a little over half coming from the midterm, a little over a quarter coming from the final, and the remainder of it is made up through the homework and study guides. All of this stuff is in the Canvas gradebook. For this class, I use the Canvas gradebook. Don't bother looking at the WebAssign gradebook. I don't even set it up. Everything is in Canvas. That way you can go in and enter little what if scores, right? You know, what if I get an 80 on the final? What if I get, 100% on the homework? What does that do to my grade? You can enter all of those things in the Canvas gradebook, and that way you can keep track of your grade. At any time in the semester, you should know exactly what your grade is in the class. The grading scale is the normal one, 90 to 100 is an A and so on, but the top 3 points of any grade designation earn the plus. So if you get an 87 or an 88 or an 89, that's a B plus. And it cascades down in the normal way. One of the things people often ask me at the end of the semester, oh, if I have an 89.75, is that going to be rounded up to an A? Yes, it will. If you're within 0.5% of the next letter grade, I will always round up. If you're within 1% of the next letter grade, then it's a maybe situation depending on your exam average. But yeah, that's the grade and point breakdown. The next page of the syllabus is pretty boilerplate stuff. The GELOS, General Education Learning Outcome. This is something that you don't need to worry about at all. It's a statistic that the state asks us to track, having to do with quantitative reasoning. It's not going to show up on your transcript. It doesn't have any bearing on your grades. Nobody will ever know whether you got the GELO or not. It's just something they use to grade our success as faculty. The next one, academic integrity, is a big deal, especially right now. So the whole reason I'm implementing the second camera with Zoom on your phone is because last semester on the final exam, I caught 9 people cheating, which is fucking offensive. I apologize for the language, but there's just no other way to say it. This stuff has gotten way out of control. I know that in the spring of last year, everybody was like thrashed by COVID and had no idea what to do. And there were a lot of things that weren't handled well. And so a lot of people ended up feeling very stressed out and you know, made bad decisions regarding academic dishonesty. And a lot of professors were sympathetic about that because of the situation. And I think some of that bled into the summer and even into the fall, but no mas. We are cracking down on this and we are cracking down hard. So I would recommend that everybody take a look at this link. These are the rules that you guys are expected to follow and will be judged by if there was a conduct trial. There's a question in chat, what happened to those 9 people? Different things. I alert Dan Rodkin, who's the chair of student conduct, and then he handles things as he sees appropriate. I send him my evidence and he reaches out from there. I had some students get a ZF in the class, which is a pretty brutal result where you fail the class and you get a mark for cheating. I had some students lose a letter grade. I had some students who just got a little warning letter saying, hey, we saw this. If anybody sees this again, you're in real freaking trouble. So it depends on the level of the offense. But here are the rules. I know it's long, it's 23 pages. I'm definitely not going to read it right now. But in the same way that when you sign a contract, you should read the contract, or when you know, anything like that, where you are going to be held accountable for, according to specific rules, you really want to know those rules. Strongly encourage you guys to go in here and read this. So take a look at these rules, make sure that you're comfortable with what they say, and you know, you don't accidentally step over some line that you weren't aware of in the past, because just like in big boy law, ignorance is not an excuse for breaking the rules. All right, coming on down, the ADA, Americans with Disabilities Act. If you have any sort of testing accommodations associated with the DRC, or you think you might be entitled to those accommodations, whether the DRC has registered you or not, please reach out to me. If you have horrible test anxiety, but you haven't seen a doctor about it or anything like that, you can still talk to me, and I'll work with you as much as I can. It's important to me that everybody feels welcome and accommodated in the class. I'm not interested in putting you through hell you don't deserve. I just want you to learn the mathematics. And if there are some things we can do to make it easier for you to learn the mathematics and then demonstrate your knowledge, I'm happy to do those things. I do recommend trying to go through the DRC, but at the same time, I know that they can be a little bit slow in the uptake. So if you are working with the DRC or have worked with them in the past, please reach out to me, make sure I've gotten the accommodation letter from them, and make sure we have a conversation about how you'd like those accommodations to be met. If you think you're entitled to accommodations but haven't worked with the DRC, please first do try to register with them, but then also separately reach out to me via email or Canvas message, and I can set up some accommodations even if the DRC hasn't figured everything out yet. Accessibility is along similar lines. I prepare all the materials for this class in LaTeX, which is a markup language that compiles into PDFs, and that is usually compatible with screen readers. Even the mathematics should work well with all sorts of accommodation accessibility hardware. But if for whatever reason you're having trouble accessing the materials or reading the materials or getting things submitted correctly, any issues at all like that, don't hesitate to let me know. I can get hardware for you. I can help you access things like screen readers, printers, scanners, phones, webcams, whatever. Discrimination and harassment. This is not usually something I have to do much about, but it's worth saying that, again, everybody who's here deserves to be here, deserves to be heard, deserves to feel welcome. So please just be polite, be kind to each other, be kind to me, be kind to staff and other faculty at Santa Fe. Everybody deserves respect. Student rights and responsibilities. This is similar to the academic integrity thing. I would recommend reading these just so you know what standards you're being held to. And then I have down here an extra note on cheating. I think I've said most of this stuff already, so I'll be brief about this. I know COVID messed up the world, and a lot of people had a hard time the last few semesters. And a lot of faculty have been waffling back and forth on how heavily to penalize things that they suspect are not honest. I am done being patient with that. So I'm not going to be in any way loose or accommodating of cheating. So even if you've gotten away with some of this stuff in the past, I promise you we know. Faculty gossip worse than like 7th grade girls. I promise you we know when you cheat. And I'm not going to show any patience for this stuff anymore. So the way it's going to work is I'm going to review the honor lock videos, all of them while I grade. And I'll also be watching you guys live on Zoom, and I need to be able to see your hands in the desk and everything like that. Just to be very clear, using anything like Photomath, Wolfram Alpha, Bartleby has been popular lately, Googling questions, answers from Quora, subreddits, anything at all, GroupMe, Discord, any of that shit is cheating. And if I catch you doing any of that, it's just straight to Dan, and then I'll let the conduct board sort it out. I really don't want that to happen. So if you're feeling that sort of pressure, I know that pressure. I know everybody has felt it. If you're in that situation where you're like, I'm screwed, I'm fucked, I have no idea what I'm going to do about this test, I got to blank, where blank is anything above or anything that smells or sounds at all like any of those things above, please just send me a message. That's all. Just send me a message saying, I'm struggling, I'm panicking, I know this isn't going to go well, what can I do? I'll work with you. All right, I can move test dates around. I can get you extra tutoring. I can work with you one-on-one. There's lots and lots and lots of stuff I can do to be helpful. So please, instead of doing something illicit, cheaty like that, just reach out to me and let me know the situation you're in. I promise you I'll work with you to help it come out well. That matters to me, right? Again, my goal here is just to convey the mathematics to you, to help you learn the mathematics. I don't like honors trials. I don't like doing any of that stuff, but we have to keep these degrees valuable. These degrees won't be valuable if we let people cheat through classes. So I'm going to be very, very rigid about this. And I'll ask that you guys please just be honest with me. If you can be super duper honest with me, I can be super duper helpful for you. But once that trust is broken, there's really not much we can do to repair it. All right, that's enough of me on my soapbox preaching about that shit. Here's the calendar. It's approximate. The things will move around. This isn't set in stone, and I guarantee you by week 5 or 6 or 7, something will have shifted somewhere else. But this is a rough outline of what we're going to be doing when. So the first week, we're going to be talking about some methods from Calc 1, like substitution, finding areas, and average value. Week 2, we're going to start talking about volume problems. These are all very heavy in graphing. And then weeks 3 through 5 are all going to be methods of integration. So a bunch of different tricks for solving hard integrals. After that, we're going to move into this middle part of the course, which is all about convergence and infinite processes. So what happens when you've got a list of numbers that goes on forever, when you're trying to add up infinitely many things, or you're trying to calculate the area of a region that's infinitely wide, all that sort of stuff. This tends to be conceptually one of the harder parts of the class. We will have exam 2 somewhere right around here. I may push this back before spring break because I found that having an exam after break is not always great. But it depends on how quickly we move through this material. The next portion of the class is on power series. These are kind of combining the idea of sequences in series with polynomials. So you have infinitely long polynomials, which can be used for approximating more complicated functions. It's a beautiful, beautiful bit of theory, but it's very calculation intensive and requires you to be 100% comfortable with the convergence material from exam 2. This is sort of the hardest part of the class. power series, Taylor's theorem. So I pair it up with the easiest part of the class, which is parametric curves and polar coordinates to kind of balance exam 3. Okay, so exam 2 tends to be the toughest exam. It's all convergence. Those are conceptually very, very hard. And then power series is actually the hardest material in the class. So in order to make exam 3 less brutal, we pair it up with the easiest material from the class. And then that's it. That is Calc 2. The final, again, 4/27. Make sure you have that in your calendar. It's 1 to 3 p.m., not our normal class time. So if you're just depending on hearing about it in class or coming to class at the normal time on that day, that will not work. That's the syllabus. So did you guys have any questions for me?
Can you hear me?
Yep.
For the double proctoring thing that you got set up, do you want like microphones to be unmuted during the Zoom call?
That's a good question. I think probably I'll mute you guys by default, and then I can come in and unmute as needed. That way we don't have unintentional chatter going back and forth. But this is my first time doing the double proctoring thing, so I'll have to feel that out, to be honest. Probably mute.
Because one thing that gives me a lot of anxiety, at least with HonorLock, is it doesn't want any background noise, and I live with my family, and they've got things that they need to do. So like HonorLock can't really tell if I'm saying, hey, the answer to the question is this, or please go away, I'm taking an exam. So
yeah, don't stress about it. If HonorLock does flag you for something like background noise, I'll check it, and if it's clearly somebody just chattering in the background or cooking noises or an alarm going off, I'm definitely not going to dock you for anything like that.
I appreciate
I'll use common sense and review everything, but probably the mics will be muted by default. Any other questions here?
Can you hear me?
Yes, I can. Yes.
You said that you wanted our phones to be recording like our desk in our hands during the test. Is that correct?
Yes.
Does that mean that we're going to need like some kind of tripod for our phones to have them set up to record that, or how do you want that to be done?
When I tested this, I used a coffee cup. Just
Okay.
got a mug sitting on my desk and leaned it against that. Anything is fine. It doesn't have to be fancy.
Okay, thank you.
Of course. Any other questions about the sort of bookkeeping syllabusy stuff here?
I had one question.
Sure, Lydia, go ahead.
In terms of your cell phone policy, I understood that you said no distracting technology. In terms of using technology to take notes, do you have any policies on that or anything that you don't like about that?
No, that's fine. In fact, some of the nicest notes I've ever seen have been taken on tablets using styluses. So whatever you like to do there is fine.
Okay, thank you.
Of course, yeah, thank you.
Hi, I have a question about the test.
Sure, Maya, go ahead.
Is there any, do we have to take it at a certain time and date, or is it like, oh, you have, okay.
So this is a synchronous class rather than an asynchronous class. And the way they work is they will be during class time.
Okay.
So it'll be like on the day of the test, instead of coming to a Zoom meeting for the test, you will, well, actually, I got to think about this now because we're going to be using Zoom too. But it'll be during class time, yes. And you'll open the test by going into Canvas. You'll go to assignments, and you'll see here, for example, it says exam 1, take the test here. You would click this. This would open up the test and launch HonorLock, and it would be only available during class time. Usually what I do is I add 30 minutes at the start and 30 minutes at the end to allow for any tech issues that show up, but it'll be open just for a window of time right around the class time.
Okay, thank you.
Of course. All right, what else is on our minds?
What would like a calculus lab involve? Because I know like with biology or chemistry labs, it's pretty straightforward, but I'm a little confused as to like, what would we be doing on Thursday?
So most of the labs will just be problem solving sessions, like a recitation, if you've heard that term before. I think that's what they call it at MIT, where you guys will say, hey, can you show me how to do homework 5, problem 12? And I'll show you how to do that and take feedback from y'all. But there are some actual labs. Approximate integration lab, this one's fine. So here's a lab that I used previously when we were doing in-person labs. I would give you guys a piece of software called Maple or something similar to that. It's called a computer algebra system, and then give you some problems to investigate numerically using those computer programs. Now, this particular lab, we're probably not going to do this term because, again, Maple is hard software to use, and it's much easier if I can like sit there with you and coach you through how to use it. So most of our labs are just going to be problem solving sessions, but there will be some labs where I ask you guys to open up Desmos and compare graphs, or make rough estimates using the computer on the size of some integral or on the size of some sum, things like that. All right, any other questions? Okay, well, thank you, Ethan, Maya, Lydia, and Alex. Let's get into some of this material then. So the first thing I want to do is address a little bit U substitution, because I know that a lot of Calc 1 classes really don't give this the time it deserves, and it's such an important technique. We will use it all through the semester. Oh, a good rule of thumb, by the way, anything I write on this doc cam should go into your notes. So the basic rule looks like this. If you have an integral where somewhere in there you see a composite function, right? Like a function of a function, like sine of e to the x. And you also see the derivative of that inner function, then you can make a little substitution. You introduce a new variable. Usually people use the letter u. And then you calculate the differential of that new variable in terms of the old variable. And that allows you to rewrite the original integral in terms of this new variable. And all of the magic comes from this piece right here. If u is u of x, some function of x, then remember from Calc 1 that the differential du is u primed of x times dx. This is really a consequence of du over dx equals u primed. That's sort of the Leibniz notation that you guys may remember. So this piece can be replaced by du, which you see here. And then this guy I can think of just as f of u, as though u is the independent variable, even though originally x was the independent variable. This is one version of the theorem. There's another version of the theorem for definite integrals. Those are integrals with bounds, remember. And I'll show you, rather than writing out that theorem separately from this because it looks a little bit confusing, I'll just run through some examples and show you how to do that. When I want to do an example in class, I will write the letters EG on the left. It's a Latin abbreviation, just means for example. So for example, if I wanted to do that integral I mentioned ago, sine of e to the x, maybe I want to integrate sine of e to the x times e to the x dx, like this. At a glance, looking at this function, I have no idea what an antiderivative for him looks like. That's a fairly complicated function. I could differentiate it, and if I wanted to differentiate it, this piece would require the chain rule, so altogether I'd need the product rule with the chain rule inside. It's a little bit complicated, but the fact that one of the pieces looks chain rule-y is a good hint that we need to use substitution. Really what this theorem is a backwards chain rule. So because I've got like an inner function and an outer function here, this hints at a little substitution. And I want to look around and see, is the derivative of this inner function floating anywhere in my integrand? Now the derivative of e to the x is e to the x. So yeah, thankfully, there it is. The way we make this go, is we come off to the side and we say, all right, I'm going to invent a new variable. We'll call it u. And in terms of the old variable, u is e to the x. So my inner function here is what I label as u. Then I calculate du. You do this just by differentiating. So the derivative of e to the x is e to the x. So du dx would be e to the x, which means du is e to the x dx. And when you see me do this in class, I'll always put it in a little box like this. Under that substitution, this integral becomes sine of e to the x, that's the sine of u. And then this piece, e to the x dx, is du. So we don't get another u from this e to the x. E to the x times dx, that whole thing is du. So this just becomes integral of sine u du. In other words, we go from problem like this, which says find an antiderivative of sine e to the x times e to the x when differentiated with respect to x, to a problem like this, which says just find an antiderivative for sine of u done with respect to the variable u. Much easier. Okay, quick memory check here. What is an antiderivative for the sine of u?
Negative cosine.
Yeah, beautiful, negative cosine, right? If you differentiate cosine of u, you get negative sine of u. So if you differentiate negative cos of u, you get positive sine of u. So the answer to that indefinite integral written there in terms of the variable u is negative cos u plus c. Remember, for indefinite integrals, those are integrals without bounds, we always write a plus c at the end. And this stands for all the vertical translates of that function, right? Negative cos u plus 5, negative cos u minus 10, all have derivative sine u. And then the last thing you need to do for these indefinite integrals by substitution is to rewrite this answer in terms of the original variable, right? If I asked you this question and you gave me this answer without any of the stuff in between, I would be like, what the hell is u? I don't even know what you're talking about. Well, what is u? U was e to the x. So this is negative cos e to the x plus c. This should all be familiar from Calc 1, but I know it's more than likely that at least some of us are a little rusty. So I'd like to do a few more examples. Any questions first, though, on this guy or on kind of the statement of the rule? Okay. So let's try one more example with an indefinite integral, and then we'll move to some examples with definite integrals.
I have a question.
Sure, go ahead.
Will you be uploading these notes on Canvas?
I will be uploading the video, which of course captures the notes, but I won't be uploading the notes as PDFs or anything, just the video.
Okay. And like at the end of class?
It takes some time. The video has to process on my local machine, then I have to wait for it to upload, then it has to process on YouTube. But as soon as it finishes processing on my local machine, I'll upload it to YouTube and paste the link. Then as soon as it finishes processing on YouTube, you'll be able to view it.
Where can we access the link?
It'll be the same place. I'll show you what I did for my earlier class today. So my college algebra class met at 9:30 this morning. The link where you find the message, the Zoom meeting link, I then go back and upload it with the YouTube, or update it with the YouTube link.
Okay, thank you.
Not a problem. All right. Any suggestions on what substitution we could make here? This one's a little harder to spot.
Could we do 1 plus 2e to the 2x?
That's a reasonable attempt. Let's see what happens if we try to do that. So if I make u 1 plus e to the 2x, what is du going to be? What's the derivative of 1 plus e to the 2x?
2e to the 2x.
Very good. Yeah, the 1 differentiates to 0. E to the 2x, that's a chain rule derivative. That would be e to the 2x times 2 dx. Here's the challenge. You've got to find this thing, the du, in here somewhere. So the bottom is going to be u. The only other piece I have floating around is this e to the x. Now this 2 right here, I can fudge him in by dividing both sides by 2. I could say 1/2 du is e to the 2x dx. But I still have an e to the 2x there, where I have an e to the x here. So the question becomes, what do I do with this? With this guy. Remember what
If u was equal to 1 plus e to the x, then you could just, for the bottom term, have u squared, or du squared, correct?
That's getting closer. Let's take a look at that really quick also, because I feel like that's a good step in the right direction. If I let u be 1 plus e to the x, then it's true that du is now just e to the x dx. This is nice because I have an e to the x over here that I can group with that dx. Without implementing the substitution, I'm just going to rewrite the problem. Everybody agrees that these are the same, right? Having a factor of e to the x upstairs is the same as having a 1 there and an e to the x over here. When you multiply these two things, they're fractions, they multiply straight across. So now here I could have my du, right? Du is e to the x dx. That piece would work. But this is now going to be harder to write in terms of u, because u squared here would be 1 plus e to the x all squared, which has some cross terms. That's 1 plus 2e to the x plus e to the 2x. So this piece wouldn't actually be u squared. It doesn't quite work, but we're definitely getting closer. The fact that e to the x itself squared is e to the 2x is useful. Let me take this. So again, this guy doesn't work. This guy doesn't work, although they're both reasonable things to try. I'm going to rewrite this integral a little bit further here. Like this. Remember, there's this rule from algebra. Oh, I don't have my side notes. All right. There's this rule from algebra that says a to the b all raised to the c, if you have a thing like that, is the same as a to the b times c. So e to the 2x is the same as e to the x all squared. From this line, can anybody see a substitution that would work?
e to the x.
Yeah, just good old-fashioned e to the x. Because then du is e to the x dx. So here's my du, and this will become 1 over 1 plus u squared, which might not look like a super easy integral, but if you spend a second thinking about it, I bet we can figure it out. Who has a derivative that looks like that?
Tangent.
Oscar? Yeah, something tangenty.
Inverse tangent.
Yeah, exactly. The inverse tangent or arctangent function, however you like to write it. I use the inverse notation like this. The derivative of the inverse tangent of u is 1 over 1 plus u squared. So the integral of 1 over 1 plus u squared is arctan or inverse tangent of u. And now the last thing we do is go back to the original variable. Oh, here we go. That keeps most of it in frame. Now, a neat note, you can check these, right? You can always check your indefinite integrals by differentiating. if we apply d dx to the inverse tangent of e to the x plus c, the plus c will differentiate to 0. And this piece is a chain rule derivative. It'll differentiate to 1 over 1 plus whatever's inside the inverse tangent squared times the derivative of what's inside. That's the chain rule. Well, the derivative of e to the x is e to the x. And then, yeah, just a little bit of algebra. E to the x over 1 plus e to the x all squared is e to the 2x. And this is our original function, right? There it is. So you can always check your indefinite integrals by differentiating. It's the nature of the beast that oftentimes there's more than one way to write a correct answer. And because of the kind of fudge factor of these plus c's, especially with trig problems, there can be some very different looking answers that are all correct. So the fastest way to check usually is to differentiate. Any questions on this guy? Any? Okay. I'd like to look at a few examples involving definite integrals and maybe some substitutions besides just e to the x. So let's fiddle with a couple of those. Let me pop open. I have here a PDF of the textbook. Oh, it's not open. Here we go. You scroll through and look for fun problems. Oh, yeah, these are classic. Let's do. I got it here. How about the integral from negative pi over 2 to positive pi over 2 of the cosine of 1/2 t dt. So here we have another thing that looks like if we differentiated it, we'd use the chain rule. So that's a strong hint that we'll integrate using substitution. But now it's a definite integral rather than an indefinite integral. And there's a sticking point here that's very important to me. When you do a substitution in any definite integral, you need to change the bounds. I know that some Calc 1 teachers say, well, you know, you can go back to the original variable at the end and then use the original bounds. Bullshit. Don't do that. Don't do that for a million reasons. Don't do that. But most importantly, if you don't change these bounds when you substitute, the original integral will not be equal to your next step. If you want to have a chain of equalities, this equals this equals this equals the answer, you must change the bounds as you go. So I'm going to show you how to do this. First, though, can somebody suggest a substitution? What should I substitute to integrate cosine of 1/2 t?
1/2 t.
Yeah. Yeah, if this was just cosine x or cosine u, I know how to integrate that. So let's let u be 1/2 t. What is du going to be then?
Just 1/2.
1/2 dt. Yeah.
Yeah.
Okay, now there's a little challenge here. I don't have a 1/2 that I can group with this dt, right? There isn't a 1/2 floating around inside my integral. I've got the 1/2 inside the cosine, but that, you know, that's what I'm substituting for, is that 1/2 t inside there. So how do I handle this guy?
Multiply cosine by 2 and then also multiply it by 1/2, and then there's your 1/2.
That works. Another way to, so one of the suggestions was to rewrite the original integral with a 2 and a 1/2 in here, right? You can multiply and divide by 2, then the 2 will pop out. and you can regroup the 1/2 with the dt at the end. This is kosher, and it's a perfectly fine way to think of things. Now this would be my du. This will be cosine of u. But there's one other thing I need to do, and that's address these bounds. So let me show you how I do that. In my little box, I like to put a vertical line to separate the differential work from the bounds work. And over here, we just say, well, when t is my lower bound, what is u going to be? Remember these bounds, these original bounds, the -π/2 and π/2, those are bounds for the variable t. So when t is equal to -π/2, my original lower bound, u, is equal to 1/2 times -π/2. Which is -π/4. And when t is equal to my old upper bound, +π/2, we just plug that in here. 1/2 times π/2 is π/4. So to get your new bounds, you plug the old bounds into the substitution. Right? My new bounds are going to be -π/4 to π/4. This too is going to come along. I have integral -π/4 to +π/4, and then cos u du. So take a second to look at what I've written here and make sure you understand where it's coming from. This process of changing bounds is important.
How did you extrapolate first that t was π/2? I think that's where it's tripping me up.
So I take the old bounds, which are -π/2 and π/2, and those are t values, right? Let me draw a picture here. Actually, this is a good excuse to introduce Desmos. So I'm going to pop open the Desmos window. And let me graph cosine of 1/2 t. Y equals cosine of 1/2 t. There it is. Now, when we say that I want to integrate from -π/2 to π/2, it's graphing it as an independent variable. That means I'm really looking at this part. I'm looking for the area bounded by this guy. So let me put the red on top. Right? The blue is the full graph of cos 1/2 t. And what we're saying when we want to integrate from -π/2 to π/2, I want to find the area under the red part of the curve, right? So the left endpoint here and the right endpoint here, those are the bounds. -1.57 and 1.57 are -π/2 and π/2. Those are t values. So these original bounds, the -π/2 here and the +π/2 here, those are values of the variable t. This says take this function from t equals -π/2 to t equals +π/2 and find the area. So I take the old bounds and I plug them into the substitution. The substitution is u equals 1/2 t. So when I have this -π/2, that's a t value that I'm going to plug into this expression to find my new bound. When t is equal to -π/2, u is 1/2 times t. So u is 1/2 times -π/2. You plug the old bounds into this relation to get the new bounds. Is that clarifying?
Yeah, I understand how you got that. Why do we need new bounds?
Another good question. So if we look at the graph of regular old cosine, here's the green graph. If I integrate this guy from negative pi over 2 to pi over 2, I'm going to get a totally different area than I would integrating the blue guy from negative pi over 2 to pi over 2, right? The area under the green graph from here to here is very different than the area under the red graph. The red graph is taller, so it will have more area. So I need to change those bounds so that the areas match. Oh, sorry, U here, sorry. So the area underneath, what other colors do I have? The area underneath the orange function between those two gray dots is the same as the area underneath this red function between those two gray dots. If I use the same input values, the same boundaries for the integral of the orange function, that would have me integrating from like here to here. That's way more, or way more than it should be. So we have to change those to match this area. It's actually really cool stuff. What you're doing here is called a coordinate transform, and I have a page, I think I put it in your modules. Oh, wrong class. That explains this in detail. Oh no, that's cup one, damn it. Damn it. Sorry, I got butterfingers here. So there's a good stack exchange page, changing bounds. Okay, I'll find it and put it in your modules there. There's a really nice stack exchange page that discusses why you need to change the bounds. But basically, it's because it's a new function. You're changing the variables. So we have to change the old bounds, which were values of the old variable, into new bounds, which will be values for the new variable. From here, an antiderivative for cosine is sine. And we need to evaluate this between these new bounds. Some people like the vertical bar for evaluations. I like the brackets, but either one is fine. So it's a definite integral, which means rather than writing a plus c and calling it a day, we have to plug in these numbers and then subtract. So the antiderivative for cosine u du is sine u. This 2 is this 2. It just comes along for the ride. And now to finish the problem, I have to plug in some bounds. I plug in the upper bound first, so I'll have the sine of pi over 4. And then we subtract what we get when we plug in the lower bound, which is the sine here of negative pi over 4. And there is no plus c for definite integrals. Definite integrals are a number, just one number. These are values that we need to know from the unit circle. So the sine of pi over 4, what is that? You can hold spacebar to talk or type in chat.
Square root of 2 over 2.
Good. And what about the sine of negative pi over 4? Oops, sorry, I wrote. There we go. Is negative root 2 over 2. Sine is an odd function, so this negative you can think of as popping out. So at the end of the day, I've got 2 times root 2 over 2 minus minus here makes plus root 2 over 2. When you add root 2 over 2 plus root 2 over 2, you get root 2. So this is 2 times the square root of 2, or just 2 root 2. Questions on this fella? So I want to say one more time just how important it is that we get used to changing these bounds. It is something I look for and grade for on tests. If you do a definite integral and make a substitution but don't change the bounds, I will take off a point. Any questions or comments on this guy? Okay, we've got about 5 more minutes. I'm going to do one more definite integral like this, and let's make it something of a slightly different flavor. How's about, I think I have something along these lines in your homework. Da, 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 da. How's about this guy? So that's the definite integral from e to e to the 16 of 1 over x times the square root of the natural log of x. Any ideas what we could substitute for here?
ln of x.
Yeah, natural log of x. Now I'm going to do something a little funny. I'm going to use the variable z in my substitution. And I want to encourage you to play around with different variables yourself, because next week, week after next, we're going to start using the letter u to mean something very specific. So the recommendation was to sub z equals ln of x, which means that dz would be 1 over x dx. And while we're here, because it's a definite integral, we're going to change our bounds. If x is equal to e, then z is equal to what? What is, if I plug e in for x here, what do I get? What is the natural log of
1.
Very good, 1, right? I'll write it as ln of e, which is 1. And when x is equal to e to the 16, then z will be the natural log of e to the 16. What is that?
16.
Good, yeah, 16. Remember, the natural log is the inverse of the base e exponential, so they undo each other perfectly. Which means my new integral, well, first I'll rewrite this guy in a way that helps us see what to do with the differential a little more carefully. So I've got my 1 over the square root of the natural log of x. And then this other x downstairs, I'm going to peel that off and write that as 1 over x dx like this. Again, this is kosher because fractions multiply straight across. X times square root log x is my original denominator. And now you can see that this piece is dz. This game of making the differentials fit is the whole thing with substitution. Cannot ignore the differentials. If you ignore the differentials, you get these wrong every time. So I had to find my 1 over x dx in there somewhere. I just peel it off like this so I can see it more easily. 1 over x dx is dz. This piece is going to become 1 over the square root of z, because z is the natural log of x. So my integral, after I implement that substitution, will go from no longer e to e to the 16, but from 1 up to 16. My new bounds, 1 over root log x is going to be 1 over root z. And 1 over x dx is dz. And this, I think we'll all agree, is a lot easier to work with than this. And you'll get to a place where this intermediate step, you don't need to write so much, but it's nice the first few times you do this, or while you're reminding yourself where things come from, to actually go through that process of peeling off the differentials as you need them and trying to ask what's left over, being very careful with your bounds. So, you know, waste the paper, right? Write a lot, take up space. Don't try to cram things into small space or skip steps. Write things out, be very verbose and make sure you're doing it exactly correct. How do I integrate 1 over the square root of z dz?
Natural log of square root of z.
This is, I'm actually glad you said that. It's not quite correct, and it's a common myth. Integral 1 over f of x dx is in general not the natural log of f of x. This only works for 1 over x. More generally, if you want the most general way that this works is if f of x is a linear function with lead coefficient 1. So we need something a little bit different there. It's a reasonable guess, and I see where it comes from, but it's not correct in this case.
Square root of z over 2.
We're getting closer there. What sort of logic did you use to think your way through that?
Well, I thought it looked pretty similar to when you have to find the derivative of a square root. You get 1 over 2 of whatever's in that square root.
That's good. Yeah. So let me pause you on that for just a second. If I want to differentiate g dz, the square root of z, if I just had to do this, you don't need to write this down. It's just a side note. If I wanted to do this, the way I do it is by rewriting that as a power function, right? I rewrite that as z to the 1/2, and then I can use my power rule. I get 1/2 z to the negative 1/2. Yeah. The same trick is useful going the other way. In fact, you could infer from this the answer here, but to be nice and explicit about it, we rewrite this as a power function. 1 over the square root of z is 1 over z to the 1/2. I'll always cross my z's. I'll never cross a 2, which is integral 1 to 16 z to the negative 1/2 dz. Now we've got a power rule for integrals. You add 1 to the power and then divide by the new power, right? So in general, if you need to integrate z to the p dz, that's z to the p plus 1 over p plus 1, right? Plus a constant if you're doing the indefinite integral. This works for all p except negative 1. Well, here my power is negative 1/2. That's not negative 1, so I can use my power rule. So the antiderivative here is z to the negative 1/2 plus 1, which is positive 1/2, and then you divide by that new power. All right, so I add 1 to the power and then divide by the new power. When you add 1 to negative 1/2, you get positive 1/2. So this is my antiderivative, and I need to evaluate it between bounds. I can clean up this divide by 1/2. That's the same as saying just multiply by 2, and I can pop that out of my evaluation brackets. That looks a lot nicer. And then I can actually do the evaluation. So this is 2 times 16 to the 1/2 minus 1 to the 1/2. 16 to the 1/2 is 4. It's the square root of 16. So this is 2 times 4 minus 1, which is 2 times 3 is 6. So there's a couple fun things there, right? Integral of 1 over something is not usually going to be a natural log. Only if the thing downstairs is a linear polynomial will that be a natural log. All of the other times, you're going to need to do something else. If it's just 1 over some variable or 1 over some power of some variable, then you can use the power rule. If it's 1 over something more complicated, like a polynomial with multiple factors or something like that, then you'll need some other tools. Questions on this guy? All right, I'm going to zoom out a little bit so we can get the whole problem in frame here. I know that we're about 5 minutes over time, so I will not keep you past this. Maybe here we can get the whole thing except the evaluation step in frame. So if you'll bear with me for 10 more seconds, I'm going to leave this for anyone who still needed to write, and then I'd like to show you one little piece of the textbook and I'll let you go for the day. Quick note while I'm letting people write, the first homework assignment again is up and it is due at the start of class next Tuesday. It's going to take you about 3 hours. It's a long homework assignment. And most of the homework assignments in this class will take you about 3 hours. So please budget accordingly with your time. The little bit of thing I wanted to show you from the book before we depart is a table of antiderivatives from the end of Calc 1 that you may want to refer back to. You may want to relearn in case you've forgotten them. It's in section 5.4. Here. Y'all are responsible for all of this. All right. The one exception is this at the end. I don't think most Calc 1s at Santa Fe teach hyperbolic trig functions, so I won't hold you responsible for that. But everything else here needs to be known by heart. This is on page 403 of the textbook. If you have the full textbook, it's about halfway through section 5.4 if you have some other version of the textbook. And it's just your basic antiderivatives, the stuff that we need to know by heart. That is all I have for you guys today. Please get into that homework and start practicing. I think good practice here would be to open that homework and do at least 2 or 3 of these problems right now. That will reinforce what we've talked about. And if you get stuck on anything, don't hesitate to send me a Canvas message. You can snap a photo of your work and share that with me. That's a very effective way to share it. And I will reply quickly with some tips and help. Is there anything you guys would like to ask about before I end the meeting for today?
No, have a great day, Professor Filesticker.
Thank you. Anybody else have any questions or comments?
Will you have any office hours after this class?
So right now, I only have the 1 office hour scheduled for Tuesdays, but if there is demand for it, I can add an extra one. Today, I have to go look at a house. I'm moving soon, so I can't do 1 extra today. My next office hour, according to my current schedule, would be tomorrow at 1 p.m. But if there's something you want to talk about, if you're wanting to talk about problems or anything at all, send me a Canvas message and I can give you a good reply, and maybe we can schedule an extra office hour between now and then if need be. I do have office hours on Tuesday, Thursday. They're just before this class. They're 11 to 12. But I'm open to the idea of adding more if it's called for. Who was that asked about office hours, just so I can keep track in my mind?
Cody Britton. I just need to speak to you about something.
Okay, yeah, sure, Cody. Go ahead and send me a Canvas message, and we'll set up an office hour if we need to. Any other questions before we end the day?
How long have you been growing the beard?
I think I shaved clean last time about 2 years ago. Oh no, it was less than 2 years ago. I don't know, between 1 and 2 years, somewhere around there.
It suits you.
Thank you, that's very kind. If there are not any other questions right now, let me see, do I have that? Integration by substitution, here it is. So I was asked earlier, why do we need to change bounds when substituting in integrals? I'm going to paste this into chat and I'll also add it to the modules. This is the best explanation I've seen. It talks a little bit also about differentials and why the differential changes things, but it's mostly just about coordinate transforms. It's a pretty good page. If you take the time to read it clearly, you'll understand, I promise. But with that, I will go ahead and end the meeting. I'll leave it open for just a second in case anybody wants to paste or copy that out of chat. But that is it from me, guys. I hope you have a lovely rest of your day. Please do get into WebAssign. Do work on a few problems right now if you can. but before the end of the day for sure. Even if you don't have your access code yet, you can get in with the temporary access. And if you have any troubles, please don't hesitate to send me a message on Canvas or an email. All right. I hope you guys have a lovely rest of your day. And I will see all of you on Thursday. Remember, Thursday.
Thanks,
is all
Professor.
morning class. All right. Take care. You're welcome.